Welcome to Best Academy TV. In this video, we're gonna focus on Gauss' law. Before we solve some questions on Gauss' law, let's know the statement of the law and the concept behind the mathematical formula. Please write. Gauss' law states that the total electric flux crossing a closed area is proportional to the net electric charge enclosed by the surface is proportional to the net electric charge enclosed by the surface. Let's represent this statement in a mathematical form. Please write. Mathematically, phi, which is representing electric force, is directly proportional to Q enclosed. This Q enclosed can also be called net charge. Please don't forget here. Okay, the Q enclosed is also a net charge. It can be called a net charge when we have more than one charge. Okay, if you have more than one charge, at that point you plus the charge together to get the net charge. But if you have only one charge, we call it only enclosed charge. Please take note. If you have more than one charge, we call this charge here net charge. Please don't forget. So class, to remove the direct proportionality, we introduce two conditions, that is equal to and constants. For us to remove this sign of proportionality here, we introduce two conditions, that is equal to and constants. So we have to introduce equal to here and also a constant value here. So phi, which is electric flux, will be equal to, okay, at this point here, the constant here is inverse of epsilon naught. So this is going to be Q enclosed over epsilon naught. Please take note. Q enclosed over epsilon naught. Okay, so the epsilon naught here is a constant value. The epsilon naught here is a constant value, which is 8.85 times 10 to the power of minus 12. The unit here is coulomb square per Newton meter square. Please take note. So anywhere you see this particular symbol here, the value is 8.85 times 10 to the power of minus 12 coulomb square per Newton meter square. Okay, now this is not the only formula for electric flux. Please take note. This is not the only formula for electric flux. So before we consider the various formulas for electric flux and when to apply them, please write. Take a note here. Note that the purpose or intention. Note that the purpose or intention in Gauss' law is to calculate electric flux. Let's know the various formulas for electric flux and when to use them. Please write. Subheading, please. Electric flux formulas and their uses. Electric flux formulas and their uses. Okay, the first formula here for electric flux here, first formula here is phi is equal to Q enclosed, which is the same thing as Q net. Okay, we use Q net when we have more than one charges. Okay, but if it's only one charge, we use Q enclosed over epsilon naught. This is the first formula. So we only use this formula here when charge is given. This only concern for charge or charges. Okay. Now let's consider the second one here. That is the second formula here for electric flux. So electric flux here is equal to EA. The E here is electric field. The A here is area, depending on the shape. Okay. Now, whenever you are given electric field and you are asked to find electric flux, the formula to use is this second formula here. Now, sometimes you'll be given an angle, and at that point, you'll be asked to find an electric flux. So, whenever you're asked to find electric flux when angle is given, that is the third formula here, which is phi, is equal to EA cos theta. Why we are using this cos theta is that electric flux is a scalar quantity, and every scalar quantity will always have an angle of cos theta. Please don't forget that. Okay, so formula 2 and 3 depend on the area given in the equation. Okay? Formula 2 and 3 depend on the area given in that particular equation. So if the shape given in the equation is a circle, so the area there will be area of a circle. Please take note. So, and again, if the shape given to us there is hemisphere or hollow sphere, which you know is half of sphere, please take note, we use the area of hemisphere. So the area depends on the shape given to us there in the equation. Please take note. Before we solve equation here, please, let's look into common areas and their formulas. Okay, please write common areas and their formulas. Let's look into the first one here, the first shape here. Okay, let's look into the first shape here. The first one here is a circle. So area of a circle here, whenever the shape is a circle, the area to use is this, that is pi arrow square. The next one here is rectangular. The area here is length times breadth. Please take note of this. So the third one here, sphere. The area here is 4 pi arrow square. Don't forget this. The fourth one here is hollow sphere. You can either call it hollow sphere or hemisphere. Please take note. It is half square. Okay, hollow sphere. Okay, let me use hemisphere. Or you can call it hollow sphere. Please take note. So have this sphere here. I will have this to be 2 pi arrow square. So the last one for this here, 5, is square. The area of a square here is a raised of 2 or b squared, depending on what is given to us here. If it is length, you square the length. It is breadth, you square the breadth. Okay, so let's take question 1 here to perfect this formula. Question 1, please. Let's solve this question here. They said 2 charges q1 is equal to 10 microcoulomb and q2 is equal to minus 12 microcoulomb are within a spherical surface of radius times cm. Full stop there. What is total flux through the surface? Okay, now let's solve this question here. Solution, please. Before we solve this question here, this is what you have to understand here, that whenever you are asked to find electric flux, the law to apply is Gauss' law. Whenever you're asked to find electric flux, the mathematical law to apply is Gauss' law. Please take note of that. Okay, so Gauss' law states that when charge is given to us here, Gauss' law states that phi is equal to q enclosed, please don't forget, over epsilon naught. And this q enclosed here can also be called net or total charge. Please take note. Net or total charge. If I'm giving more than two charges, the Q enclosed will be net charge. But if I'm giving only one charge, the Q enclosed will be the charge there will be an enclosed charge. Please take note. If I'm giving two charges, the Q enclosed will be net charge. But if I'm giving only one charge, the charge there will be only enclosed charge. Okay. Now we are given two charges here. That is our Q enclosed here. So our Q enclosed will be Q net, that is the total here, which is equal to Q1 plus Q2. So our Q1 here is 10. Plus times minus is minus, that is plus, minus 12. So our answer here, class, our Q in net here, which is the total here, will be equal to class minus 2, and the unit there is microcoulomb, don't forget. Okay, so which is the same thing as minus 2 times 10 raised to the power of minus 6 coulombs. This is a prefix here, micro, and the value is times 10 raised to the power minus 6, don't forget. So the epsilon naught here is 8.85 times 10 raised to the power of minus 12 in coulomb square per Newton meter square. So let's impute the values. When you do that, we have our electric flux to be equal to phi will be equal to plus minus 2 times 10 raised to the power of minus 6 over 8.85 times 10 raised to the power of minus 12. So this will be equal to class. Let's divide here. Minus 2 divided by 8.85. We'll have this to be minus 0.226 times 10 raised to the power of minus 6. Let's take minus 12 from denominator to numerator. This is going to be plus 12. So phi will be equal to plus minus 0.226 times 10 raised to the power of minus 6 plus 12 will give us 6. Representing this in a complete standard form here, our electric field here, that is the phi here, will be equal to minus 2.26 times 10 raised to the power of minus 1 times 10 raised to the power of 6, okay, which is the same thing as minus 2.26 times 10 raised to the power of minus 1 plus 6 will give us 5. And the unit of this is Newton meter square per coulomb. Please don't forget, this is our answer here. So all you have to do to get the full series on electric field is to hit the subscribe button. Okay, thank you.